Chapter 26. Aqueducts and Plumbing. 312 BCE, Roman Empire. Access to clean water. In the history of human civilization, few innovations have had as profound an impact on urban living as the Roman aqueducts and public plumbing systems. Developed during the Roman Empire starting in 312 BCE, these feats of engineering allowed the Romans to transport fresh, clean water over long distances into densely populated cities. The availability of clean water was not just a convenience, it was a transformative advancement that revolutionized public health, hygiene, and daily life. Before the Romans perfected the aqueduct system, urban areas struggled with issues of water supply, sanitation, and waterborne diseases. The Roman solution to these problems fundamentally reshaped their cities, making them some of the most advanced urban centers in the ancient world. Access to clean water reduced the prevalence of disease, improved life expectancy, and enabled cities to grow and flourish without being crippled by the health issues that often plagued early civilizations. In this chapter, we will explore the development of Roman aqueducts and plumbing systems, their engineering brilliance, and the profound impact they had on public health and urban living. By examining how these systems worked, we will also understand how the availability of clean water laid the foundation for larger, healthier, and more vibrant urban populations, shaping the course of Roman civilization and influencing future societies. The challenge of water supply in the ancient world. Before the development of aqueducts, ancient cities faced significant challenges in securing consistent supplies of fresh water, especially as populations grew. Early civilizations like the Sumerians, Egyptians, and Greeks relied on nearby rivers, wells, and reservoirs to supply water for drinking, cooking, and irrigation. However, cities located far from large natural water sources faced a constant struggle to provide for their citizens, particularly as urban populations increased and the demand for water grew. In these early urban centers, the lack of an adequate water supply often contributed to the spread of disease. Contaminated water sources, unsanitary living conditions, and the absence of sewage systems led to frequent outbreaks of waterborne illnesses such as dysentery and cholera. Moreover, the process of fetching and carrying water, typically done by women and slaves, was limiting points by stopping up contributing to water in the first place, and the time consuming, limiting both economic productivity and quality of life. In the absence of clean water, cities had to contend with problems such as poor hygiene and inadequate sanitation, leading to filthy streets and cramped, disease-ridden conditions in urban areas. These factors made it difficult for cities to grow sustainably, as larger populations placed further strain on limited water resources. Recognizing these challenges, the Romans sought to address them by designing a revolutionary system to transport clean water from distant sources directly into their cities. The solution came in the form of aqueducts. The birth of the Roman aqueduct system. The Romans were renowned for their practical approach to engineering, and their aqueduct system stands as a testament to their ingenuity and forward thinking. The first Roman aqueduct, the Aqua Appia, was completed in 312 BCE during the time of the Roman Republic. Named after Appius Claudius Caecus, a Roman censor who oversaw its construction, the Aqua Appia was built to bring water to the city of Rome from springs located about 16 kilometers, 10 miles, outside the city. The construction of the Aqua Appia marked the beginning of a massive public works initiative that would span centuries, resulting in the development of an extensive network of aqueducts throughout the Roman Empire. Over the next 500 years, the Romans built 11 major aqueducts to serve the city of Rome alone, along with many more in other parts of the empire. Some of the most famous Roman aqueducts included the Aqua Claria, Aqua Marcia, and the Aqua Traiana. Aqueducts were designed to transport water from natural sources such as springs, rivers, and lakes, often located many miles away from the city. What made the Roman aqueduct system truly remarkable was its use of gravity to move water over long distances and varied terrain. The Romans constructed aqueducts with a very slight downward gradient, ensuring that water flowed continuously from the source to its destination, without the need for pumps or mechanical assistance. This required extraordinary precision in design and construction, as the slope had to be carefully maintained over potentially vast distances. To achieve this, Roman engineers employed a variety of architectural solutions, including tunnels, bridges, and arcades, rows of arches. In mountainous regions, aqueducts were tunneled through rock, while in flat or low-lying areas, aqueducts were carried across valleys on elevated bridges supported by arches. The most iconic example of Roman aqueduct architecture is the Pont du Gard in France, a stunning three-tiered stone aqueduct bridge that spans the Gardon River and still stands today as a symbol of Roman engineering prowess. The role of plumbing in the Roman water system. Once water reached the cities via the aqueducts, the challenge was to distribute it effectively to homes, public buildings, and other key locations. This is where the Romans developed a sophisticated plumbing system to manage the distribution of water. Water was stored in large cisterns or reservoirs, and from there it was channeled through a network of lead and clay pipes to various parts of the city. The Romans used the term plumbum for lead, which is where the modern term plumbing originates. The Roman water supply system was divided into public and private distribution networks. Wealthier citizens could pay to have water delivered directly to their homes through private connections, while public water supplies were distributed to fountains, baths, and latrines. Public fountains, located throughout the city, provided access to free, clean water for all residents, including the poor. This system ensured that even the most humble Roman citizens had access to a reliable source of fresh water. One of the most notable aspects of Roman water management was the development of public baths, or thermae, which became central to Roman social and cultural life. The Romans believed that bathing was essential for maintaining health and hygiene, and public baths were open to citizens of all classes. These baths were equipped with systems to heat water, using wood-fired furnaces and advanced plumbing techniques to regulate water temperature. Public baths became places not only for bathing but also for socializing, exercising, and conducting business. The Romans also constructed elaborate sewer systems to carry away wastewater and prevent contamination of their clean water supplies. The Cloaca Maxima, one of the world's earliest known sewer systems, was built in Rome to drain the marshes and carry waste out of the city and into the Tiber River. This infrastructure significantly reduced the risk of waterborne diseases and helped maintain the cleanliness and health of Roman cities. Public health and hygiene, reducing disease. The impact of the Roman aqueduct and plumbing systems on public health cannot be overstated. Access to clean, running water significantly improved the hygiene and sanitation of Roman cities, reducing the incidence of waterborne diseases that had plagued earlier civilizations. The availability of clean water for drinking, cooking, and bathing played a crucial role in enhancing the quality of life for Roman citizens. In ancient cities without effective water management, contaminated water was a common source of illness. Waterborne pathogens, including bacteria that cause diseases such as dysentery and cholera, could spread rapidly in densely populated urban areas. By providing a steady supply of fresh water and creating a system for disposing of waste, the Romans drastically reduced the risk of such diseases. The Romans also had a relatively advanced understanding of personal hygiene for their time. Public baths encouraged regular washing, which, combined with access to clean water, helped prevent the spread of germs and infections. The use of public latrines, which were often connected to the sewer system, further improved sanitation by keeping human waste separate from drinking water supplies. As a result of these innovations, the life expectancy of Roman citizens was likely higher than that of people living in other ancient civilizations. While the exact impact of the aqueducts on life expectancy is difficult to measure, The improved public health and reduced exposure to disease undoubtedly contributed to longer, healthier lives in Roman cities. Moreover, the availability of clean water allowed Roman cities to grow to unprecedented sizes, supporting populations that would have been unsustainable without such infrastructure. Urban growth and economic development. The aqueduct and plumbing systems also played a key role in the economic development and urbanization of the Roman Empire. By providing a reliable and abundant water supply, the Romans were able to support large urban populations, which in turn fueled economic growth. Cities such as Rome, Alexandria, and Carthage became bustling centers of commerce, culture, and political power, with populations numbering in the hundreds of thousands. The presence of aqueducts enabled the construction of large public buildings, such as amphitheaters, basilicas, and temples, which required significant amounts of water for their operation and maintenance. The availability of water also supported industries such as tanning, textile production, and metalworking, which relied on water for their processes. In agricultural regions, aqueducts supplied water for irrigation, allowing the Romans to cultivate crops on a larger scale and increase food production. The Roman economy was also boosted by the rise of trade within the empire, much of which centered around its cities. The ability to support large urban populations with adequate water supplies made Roman cities hubs of economic activity. Roads, ports, and markets were developed to accommodate the growing volume of trade, which brought goods from across the empire, ranging from grain and olive oil to luxury items like silk and spices. As cities grew and prospered, they became centers of Roman culture and identity. Urbanization fostered the spread of Roman law, architecture, and language across the empire, creating a sense of unity among its diverse provinces. The aqueducts, which were often highly visible symbols of Roman engineering prowess, also served as reminders of the empire's power and ability to transform the natural environment to meet human needs. In your engineering brilliance, how the aqueducts worked. The construction and maintenance of Roman aqueducts required a remarkable understanding of engineering and hydraulics. Roman engineers used a combination of techniques to transport water over long distances, including tunnels, siphons, and bridges. Their ability to survey land and calculate the precise gradient needed for water to flow by gravity was a testament to their skill and knowledge. Aqueducts were typically built with a very slight downward slope, often no more than 0.15 meters per kilometer, 1.5 feet per mile. This gentle gradient ensured that water would flow steadily without stagnating or rushing too quickly. Engineers used tools like the chorobates, a wooden surveying instrument, to measure the slope accurately and maintain the proper gradient throughout the length of the aqueduct. In areas where the landscape required the aqueduct to cross valleys or rivers, the Romans built massive bridges, supported by arches. These structures, made of stone or brick, allowed water to flow across low-lying areas without losing elevation. In more challenging terrain, such as mountains, Roman engineers dug tunnels through solid rock to keep the water moving along its intended course. The construction of aqueducts was labor-intensive and often took years or even decades to complete. Thousands of workers, including slaves, soldiers, and skilled laborers, were involved in the process. Despite the enormous effort required, the Romans considered their aqueducts to be essential public works, as they contributed to the overall health, prosperity, and stability of the empire. The maintenance of aqueducts was also a priority for Roman officials. Specialized workers known as equarii were responsible for inspecting and repairing the aqueducts, ensuring that the water supply remained clean and uninterrupted. Regular maintenance was essential, as the buildup of calcium deposits or blockages could reduce the flow of water and compromise the system's efficiency. Legacy and influence on modern water systems. The Roman aqueducts and plumbing systems left an indelible mark on the development of water infrastructure in Europe and beyond. Even after the fall of the Roman Empire in the 5th century CE, many of Rome's aqueducts continued to function for centuries, providing water to cities long after Roman rule had ended. In fact, some of the aqueducts built during the Roman Empire are still in use today, a testament to their durability and the ingenuity of Roman engineering. The influence of Roman water infrastructure can also be seen in the design of modern water systems. Many of the principles developed by Roman engineers, such as the use of gravity to move water, the importance of maintaining a clean water supply, and the need for proper sewage disposal, continue to inform the design and construction of water networks in cities around the world. In the 19th and 20th centuries, as cities in Europe and the Americas grew during the Industrial Revolution, the need for reliable water supplies and sanitation became even more critical. Engineers looked to Roman aqueducts as models for the construction of modern water systems, using similar techniques to bring water from distant sources into rapidly expanding urban centers. The development of modern plumbing systems, including the use of pipes and reservoirs, also drew heavily on Roman innovations. Conclusion: the Roman aqueducts and plumbing systems were more than just feats of engineering. They were the lifeblood of Roman cities, providing the clean water necessary for public health, economic growth, and urban development. By ensuring that their citizens had access to fresh water, the Romans were able to create cities that were cleaner, healthier, and more vibrant than those of earlier civilizations. The availability of clean water transformed daily life, reduced disease, and allowed Rome to grow into one of the largest and most powerful empires in history. The legacy of Roman water infrastructure can still be seen in the design of modern cities, where access to clean water remains a fundamental necessity for public health and quality of life. As we consider the role of technology in shaping human